prove by contradiction that the sum of an integer and a non-integer rational number is a non-integer. Because it's by contradiction, we start by supposing the negation. So suppose the sum of an integer and a non-integer rational is a non-integer, so is not a non-integer, so is an integer. That is the negation. The opposite of is a non-integer is an integer. Putting that into some algebraic terms, the sum of an integer, so we're going to let the first number be an integer, and a non-integer rational number, so b belongs to the rational numbers but not the integers. What that means is that b is equal to m over n, where n is not equal to 1. M and n are integers because it's a fraction, and also that the highest common factor of m and n is equal to 1, supposing that we've written this in the simplified version. And then we're saying that the sum of those two things is an integer. So putting that all together, we have that a plus b, but b is m over n, is equal to some other integer, which I'm going to call c. Okay, let's say a plus b is equal to c, which is an integer. But that means that m over n is equal to c minus a, which means that m is equal to n times c minus a. But this means that m is a multiple of n. And that's a contradiction. This contradicts the fact that the highest common factor of m and n is equal to 1, as m is a multiple of n. So the highest common factor would be n, because n is a factor of both of them. So we've contradicted something that we originally assumed. That means we've made a contradiction. So the opposite, the negation, must be true. So by contradiction, the opposite must be true. The sum of an integer and a non-integer rational number is a non-integer.